Okay, students, this is Cambridge IGCSE Physics Paper 6 Alternative to Practical, October-November 2024. Let's start with the questions. So this is question number 1. The figure represents a stack of glass microscopic slides. This is a stack of glass microscope slides. A student takes measurements from the stack of glass microscope slides in order to estimate the number of slides in the stack. Now, what is he doing? The slides of the stack have been covered with tape, so the student cannot count the number of slides in the stack. At this point of time, the slide shows, this figure 1.2 shows the the side views of the taped stack of slides given to the student. So it's all given with this length, height, and width. So this is the side view. This is the front view. You can say one of the side view is this one, and this is the side view. So you have to use the scale and you have to measure the length and the width and the height of the covered stack of the slides in centimeter to the nearest millimeter. So what you have to do, you have to use the scale, a simple ruler, and measure it. So when you measure it with the help of ruler, you will get the measurement starting from this to this is 7.5 centimeter. The width from this point to this, when I measure it on the hard copy, I get 2.5 centimeter. And the height is this one, which is 1.3 centimeter. Now the student uses a balance to measure the mass of the covered stack of the slides. The covered stack of slides, microscope slides, is given here with the balance shown here. Write down the mass of the covered slides to the nearest 0.1 gram. So the value is actually 57.87. And when we measure it to 0.1 grams, it means we have to 57.87. It means that 0.1 means that we have to take the first decimal place. We have to round it. And when we round it, after 8, we get 7. So it will be 57 point. When we round it, this will become 57.9. So the value is 57.9 grams. Okay. Now moving on to the next question of the same question, next part. Calculate the density of the glass. Use your results from A and B part 1 and the equation shown. So the mass we have already calculated the whole glass. The mass is given as 57.9. So we are going to replace the mass with 57.9. The length, width, and height we have already calculated as 7.5 multiplied with 2.5 multiplied with 1.3. So we get the density after multiplying 7.5 with 2.5 with 1.3 and then divided it with 57.9. We get the density of the whole slide as 2.37. Let me confirm the answer and the unit because the mass is given in, since you can see the mass is already given in gram and all the units of the lengths were in centimeters. So the unit will be gram per centimeter cube. Let me see the answer from the answer key because we have to completely see what are the answers. Let me show you. So the length is 7.5, width is 2.5, all values to the nearest millimeter. This is 57.9 and this is 2.3. It may be 7, it may be 5, it may be 4 and gram per centimeter cube. Till here we are all set. Next, moving on to the next part, the teacher write down the mass and the thickness of the single microscope slide on the card. Now, the thickness of the single slide is 0.11 centimeter and the mass of the single slide is also given as 4.2 grams. Now, they say that use your answer in B part 1 and the information from the card. In B part 1, the mass was given as 57.9 grams. Of the whole glass of slides, and the mass of a single slide is given as 4.2. So with these two information, we are going to estimate the number of microscopic slides in the covered stack. Now, the point is that we have two types of, the way we have to calculate the value of one number of slides in the covered stack. Maybe there are two options. One of the option is that we use the mass of the whole slides, all the slides divided by the single slide. So this way we can find out, this will be N1. So we are going to divide it with 4.2. And with that, we will get the value as 13.785. For that, we can say this, if we round it to the nearest whole number, obviously the number of slides would be 14. It might be 13 or 14. You can say 13 or 14, but we will take it to 14 this time. Okay. Then in the next part, they say use your answer in the A part. Again, the information is given in the A part, which was the what was the information in the A part. So let's move on to the A part and let's see what was the information in the A part. The information was the length, width, and height that we have already calculated. Use that information from the card in the figure 1.4. Now let's see. This one is 0.11 centimeter. Now this was the thickness. If we talk about the whole, slide of deck, only the thickness is different, rest the length and the width will definitely be the same. So what we are going to do, we first will calculate the volume of the slide. And the volume of the slide, or maybe we can use the thickness of we will take the total thickness. Okay, let me see. We can just divide the total thickness of this one. The total thickness here was 1.3. So let's take 1.3 thickness of the total thickness divided by the thickness of one slide, which is given 0.11. For this, we are going to divide, and then we will be finding the value of N2 as 1.3 thickness of all slides divided by the thickness of a single slide, which is 0.11. Or in another way, we can also do, or we can take the volume of all the slides, which will be the length and width will be the same, divided by, again, the length and width will be same. So it will be like this. We can do it. The length was 7.5 times the width was 2.5 times the height or the thickness is 1.3 divided by 7.5 into 2.5 into 0.11. Why I'm doing it? Because the length and the width will be same, only the thickness will be different. So these two will be cancelled and the answer is 11.818. And if we round it, we can get 11 or 12. So both ways you can just find it out. Okay. Now let's move on to this question. They say that two quantities can be considered to be equal within the limits of experimental accuracy. Now the answers, since we have gotten the answer as 14 or 12, so they wanted to know that what will be the answer within the limits of accuracy. So we know that the limits of accuracy answers are, and we have to state whether the values of N1 and N2 from the C part 1 and C part 2 can be considered equal. And in the next part, we will suggest that they are different. So for these values, what we are going to do, first we are going to take, we will be taking here as it was 13 and or 14. So we'll take the nearest value of 13 from this side and 12 from this side. So I'm taking the values as 13 or 12. So as we know that limits of accuracy percentage is maximum minus minimum over the average. So just let me, so I'm going to just do it with the help of that. Let me use the calculator and its maximum is, so I'll take the maximum is 13 minus 12 and the average of 13 and 12 is 12.5. So I'm going to take 13 minus 12, which is 1 divided by 12.5. And it's in times 100%. So the answer is 8%, which is within the limits of accuracy because they are within 10% of each other. So yes, they are equal. So the statement will be that they are equal because the percentage comes within 10%. Now let's see that if the percentage is different, we can say one reason we can suggest that the values are different. So for that, we will be taking, as we've already calculated that the value could be 14 or could be 11. At this point of time, if we want to make them different, we will be taking 14 and 11. So the same methodology we will be taking. And here we are going to write again the limits of accuracy, which is again maximum minus minimum by average. So maximum in this case, I'm going to take 14 minus 11 divided by, so let's take the average of 14 and 11. So average of 14 and 11 is again 12.5. And I'm going to subtract it 14 minus 11, which is 3, divided by 12.5. So get 24 times 100%. So the answer is 24%, which is why? Because the limits are more than, we can say that since the limit is more than 10%, so the values are not equal. Let me see the answer key. They say that if your answers 10% difference calculation showing candidate's value, statement matches the candidate's result. So we can evaluate like this. And the last one is that slides not at all the same mass, weight, slides not all the same thickness. The tape adds to the mass, weight, and height of the stack. So it means that we can give the reference point as that the slides are not the same. The weight and the slides are not the same thickness. And the tape adds to the mass because the tape was also added. So the height and the width can also be changed. So that's why this could be the reason. Okay. Now moving on to the next question, where this says that the student measures the resistance of the light emitting diode. And here we have, this is a light emitting diode is here. The current it changes, the student set up the circuit like this. Okay. Now we will be taking this separators. Now the students connects a voltmeter to measure the potential difference across the 220 ohm resistor. Now this is the potential difference point P and Q. Now the student closed the switch. So this switch will be closed at this point. And then student records the voltmeter reading PQ in the top row, opens the switch. So this is the whole, phenomena that the student has completed this experiment. Now on the figure 2.1, draw the symbol for a voltmeter connected to measure. So first we have to connect a voltmeter because the voltmeter always goes in parallel. So here we will write V, and this is how we have connected the voltmeter. Okay, next we have the value of the voltmeter reading. Now we can see the voltmeter reading in PQ is 2 and 3 in between. This is 2.5. So the value of the reading is 2.4. So we are going to place it over here as the value is 2.4. Now here, what we are going to do in this particular case, they asked us to write down the reading in the top row. So we have already written the top row. Okay. Now the student at this point of time disconnects the voltmeter from P and Q. Now he reconnects the voltmeter across the LED between the points Q and R. So we can see that here the student disconnect the voltmeter and the LED between Q and R. Here the student is connecting. Now the voltmeter is connected over here. This time the voltage will be across Q and R. So I'm not drawing it, but I'm just explaining you that this point and this point, we are going to connect the voltmeter in the same way like the student connected it at P and Q, along P and Q. So here what we are going to do, now calculate the current in the circuit using the equation I is equals to VPQ. So VPQ we have already 2.4. Resistance is given as the resistance between P and Q is 220. So from that we get the value of current as 0.011. Maybe it's 0.0 if you divide it some way. So I'm going to write it here in this 0.011. Now at this point, record your answer in the top row. So I have recorded. Now calculate the resistance RLED using this equation. Now we have to take VQR, which is 2.1 divided by the current that we have already calculated. So this current will be 0.011. So we are going to divide it and we will get the value. Let me divide and let me see. So I'm going to take it as 2.1 divided by 0.011. So it's 190.90. So we can say 190.1 maybe. We can even write 190.1. So it's 190.9. So I'm writing 190.9. Okay. Now at this point, record your answer again in the top row. So I have recorded it. Next, the student removes the 220 ohm resistor. Now the resistor is changed from the circuit and replaces it with 330 ohm resistor. Now again, at point P and Q, the student is reconnecting the voltmeter, repeats the experiment, and use the information in the table to calculate the value of VPQ across 330. Now all the values are there. You just need to take, because this is the voltage, this is the resistance. So we are going to take the this is the current. We're going to take the current. The current will be 0.076. So we will be taking the current and we will be taking the value of this. So I'm going to write it. R is equals to V by I. So the resistance is now 330 is equals to the voltage we have to calculate, and the value of this 0.0076. So let's multiply this and we will get the value of the voltage as, let me multiply it. So we'll get it 330 multiplied by 0.0076. So I get 2.508. So I'm taking 2.50. So here the value is 2.50 volt. Next, moving on, as the resistance between the points P and Q changes, the current in the circuit changes. So we see, use your results in the table to write the conclusion, stating how the change in current affects the potential difference across the LED. Now this is the point. Of course, they say that the resistance between the point. First, the resistance was, if we look at the resistance, the previous resistance was 220 resistance, and then there is a diode here, LED here. So what we basically have to see that if that the resistance was 220, the current was more, but if the resistance has been changed to 330, of course the value of the current increases, so the value of the resistance decreases. So what we are going to write here, so we can say that if the current decreases, of course the current decreases because the resistance increased. So we will say that the current decreases so as the voltage decreases. So the voltage also decreases and the resistance increases. Resistance across the R LED increases. So this is the result of this particular question. Okay. Now moving on to another student uses the variable resistor to control the current in the circuit. Draw the symbol for the variable resistor. Now it's very much obvious that you have to use the correct symbol. If you're not using the correct symbol, you will not get, and mostly the students are making this mistake that they are not making a perfect symbol. The perfect symbol should look like this one that you are going to make 2 lines here. So please try to learn all the symbols. If you want to excel in this, please try to learn the symbols of. So this way, this is the variable resistor. You can also see at the, bottom of the question paper, they have given, not over here, let me, bottom of the mark scheme, they have shown us some of the, this one is the correct symbol. So use a very basic and correct symbol for this one, okay? Now moving on to this one, and here we are with the question. Explain one advantage of using the variable resistor for this purpose rather than the procedure carried out in A and B. So what could be the, possible advantage? So the advantage would be, like, if we are using a variable resistor, of course, there will be continuous value of current, and you can say that when we are talking about that, we are using variable resistors. So no need to change the resistors. Rather, you will be using the resistors directly. The value of the resistance can be alternate directly. You can say no need to connect or disconnect it. And the resistance value will be easy to, change. So you can say that it's easy to change the value of the resistance, and no need to connect and resistance. So here what it is, let me just clarify that from the perspective of here. So you can see that you can avoid connecting or disconnecting the circuit. You can obtain a continuous set of values. It's easier to change the current or resistor, can obtain more values of resistance and current. Okay. Moving on to the next question. Now this is the apparatus which is shown. Here is the screen, here is a converging lens, and this is the illuminated. Now the student switch on the lamp, place the lens. Now this distance is U, which is 20.0 centimeter. Now adjust the position of the screen until a sharp image of the illuminated object is formed. So measure the distance. So you have to measure the distance again with the help of ruler. So it's 12.1 centimeter. Okay. Now here the figure shows, figure says that this is drawn to a scale of 1/5 of full size. So for example, if it was 12.1, if it is not the original value, of course the original value will be 5 times 12.1. So I'm going to multiply 12.1 with 5, and it's 60.5. So the value here at this point, when the value of U is 20, at that point the value of D is 12.1. So we are going to change this 12.1 to the original value by multiplying it with 5, because it is 1. This value is actually 1/5 of the original value. So if it is 1/5, so if we want to know the original value, we will change it to 12.1 multiplied by 5, and this will become 60.5. Okay. Let's move on. All the values are given here. We may write all the values for the next part later on, because we have to make a graph as well. Now the diagram shows the illuminated object. This is the object and this is the image. You can see the image and the object. What are the characteristics? So two ways the image differs from the object. One way is that this is a very big image. It's a magnified image. So one way you can write it's magnified or enlarged. These words are the keywords. And the other one is it's inverted or upside down. So you can write these keywords to explain the type, the properties of the image. Now they say the magnification of the image can be calculated using the equation m is equals to v by. So we have to use our answer in A part 2. So we got the value of v as, let's take the value of v as 60.5 from this. M is equals to 60.5 divided by 20.0. So let me divide it and let me get the value. I'm going to take it, dividing it. 60.5 divided by 20.0. So I get 3.025. 5, so the value is 3.02. Okay. Next question is that the student repeats the procedure for all such values, which are given already in the table. So let me write down all the values and I'm going to draw a graph. So I'm just writing all the values here for my ease. I'm writing them here for 20.0. These are all the values of u and these are the values of v. So it's 60.5. For 25.0, the value is 37.2. For 35.0, it's 26.5. Same goes with 45.0, 22.7, 55.0, it's 20.9, 60.0, it's 20.2. Okay. So by looking at the graph carefully, we have to make a proper graph and the values should be very carefully taken. Okay, at first we know that in the question they have given us that we should be made on y-axis and u should be on x-axis. So first I'm going to take all the values of u, like at 20.0 means this is 20. At 25 is this one value. At 35, then we are going to talk about 45. Then it will be 55 and then it will be at 60. Okay. At this point of time, I'm going to just take, because this is 60.5. So it means 60.5 means that first I have to, closely go over here. And 60.5 means that 60 and 61. In between 60.5. So over here, I think, let me see that where is. So this is the line and here we are going to mark the point. At this point, 25.0. So at 25.0, this is after 20, after 5 lines, this is 20 point, and this is 37.2. So 37 means that this is 35, 36, 37, and 37.5 is this one. So I'm going at the point here, over here. So this is the point. Then at 35.0, it's 26.5. So 35. So after this will be 35. And here it's 26. So I am just down. And it's 25 and it's 26 and it's 26.5. And this will be at this point. Let me clarify that if I've taken it at 35, yes, perfect, 35. And after 35, it's 45. So 45 means after 35, 10 lines here, 45. At 45, it's 22.7. So 21 and 22 and 22.7. So it's going to be here, 22.7. And then at 55, okay, this is 45, so it means 55 is here, and 20.9. So 20.9 means that it's almost like here. It will be here. In between 20 and 21, it's 20.9. And then at 60, it's 20.2, so it will be here. Now, all the points have been marked. Now we are going to join them to make a smart curve. Just a second, and I'm going to draw because we need to make a very proper graph. The graph should be very neat and very particular. So we are going to join them to make a graph. It's a bit more beautiful, I think. First I'm joining this one, join this one, then that, and that, and that. So over here I've made it. You can see this is the graph. Okay. Now, moving on to the question here, we say that use your graph to find the value of when u is 30. So we have to see that if u is 30, what is value of v from the graph? So moving on to the graph, and we will look at the value of 30. This is 30. And when we see it's almost 30. Like I've got also 30. This is also 30. When this is 30, this is also 30. So I'm going to take 30. So my value of V is 30. Now taking the values of U and V from the D part. So we have 30, using it in this one. So it will be 30 times 30 over 30 plus 30. The value of U and the value of V. So it's 30 times 30 is 3 3s and 9. 900 divided by, okay. So the value of this one is, let me take the calculator. 30 multiplied by 30, I get 900 divided by 60. So it's 15. So the value is 15 centimeter. Now state one technique you use during the experiment to ensure that the image on the screen is as clearly focused as possible. So it's important. Make sure you slowly, make sure slowly moves the screen, moves or adjust the screen until a clear image is formed. Clear and sharp image is formed. One more point is sharp image is formed. Another point is that we should be taking an experiment. The experiment should be carried out in the dark. Darkness to see the clear image. So this is just one suggestion. Okay, now this question says that there is a hot water which is poured into a glass beaker and it allowed to cool down. Plan an experiment to investigate how the rate at which the water cools. Now this is the time that the water cools depends upon the diameter of the water surface. So it means that if they are provided with the supply of hot water, set of glass beakers. So the glass beakers of different sizes, maybe the diameter is different. And then there is a measuring cylinder. For the measuring cylinder, why? Because we have to take the same volume of the liquid every single time to put it into different beakers. You may use any other common laboratory apparatus in your plan, include any other apparatus needed. So what apparatus is needed? An extra apparatus that is needed. Then a brief description of the method, including that you measure and how will you make sure your measurements are accurate, the key variables that you will control. So all these things we have to, write here. So first of all, any other apparatus. Of course, if we use beakers of different diameters, maybe different beakers. So what is the, what extra thing? Of course, to calculate the distance, the diameter of the different beakers, we need a measuring tape. So the measuring tape is required. And what else is required? Let me see. Okay, and what else? After the measuring tape, we should have a stopwatch or the timer to, see that the time, the rate at which the beakers, the water in the beaker cools down. The other thing is that what do we need else is the measuring tape, the stopwatch, and okay, and the brief description of the method, including what you will measure and how you will make sure your measurements are accurate. So the point is that the description, these beakers should be made because they say that you can include a labeled diagram if you wish. So different beakers you can make with different diameters. Like some of the beakers might have small diameters, some of the beakers might have bigger diameters. So the diameter can be, like you can shade the diameter to tell. Let me shade it with another color so I can tell that this much is the diameter. So this is the diameter here. Okay, the diameter should be in centimeter. Here it's also D. So we can write D here. Here we can write D here, right? Okay, so this is what we have to Now we have to find the temperature of all this. So I'm going to write something like how can we measure? So for that, I think we need to uh, write the description that what we will do. One more thing, one additional, I think we forgot to, tell about it. Let me just clarify one thing, and that is that I just wanted that the thermometer should also be there. So the thermometer, we can also place a thermometer in between, and we can write thermometer here. Okay. So this is all what we can write. Now what we have to write here. First, we are going to talk about that we are going to additional apparatus we are going to write first. So additional apparatus, the first thing. As I said, thermometer. Then we should have the stopwatch. Then we have the measuring tape. The first answer would be this one. These are the additional. And of course, maybe a ruler. If you do not have a measuring tape, you can use this. Okay, so this is the first, answer for this one. Next, we would like to know the answer for the constant, the thing that we need to keep the variable constant, like which thing should be kept constant, right? Okay, so the thing that should be kept constant is constant volume of water. Volume of water should be same for all the beakers. Constant volume of water, all the beakers should have the same. Initial temperature, like all beakers should have the same initial temperature. So initial temperature should be same. What else? The initial temperature should be same. And the time of cooling is also should also be same. And then what we have to write? The method. Okay. After that, we have to write down the methodology. The methodology, when we are talking about the methodology here, so here we are to write. Okay. So we should take beaker and fill it. This is what we have to write, that take beaker, fill it with water, with hot water, of fixed volume. And then we say that note the initial temperature. This should be the first step. Then we have to note down the initial temperature. And what else we can do? And let it cool for a fixed period of time. So we have to let it go and let it cool at about, let it cool for set period of time. We can say for set period of time. And then during the cooling time, we have to keep taking the values of the temperature at equal intervals of time. So this is very important point, right? During the cooling process, you can write during the cooling process at regular intervals, process after regular intervals, keep on measuring the temperature using the thermometer, temperatures. This is important that we have to measure the temperature after equal intervals of time and repeat the experiment with different diameters. So repeat the experiment. With different beakers. And then now take the, okay, the whole process should be taken with different, different beakers of different